Hello everybody, welcome back to Cloudwings Technology. My name is Bahadur and this is day 7 of our Kubernetes 0 to Hero course. So in this video, you will learn ReplicaSet and also you will see pod lifecycle. So this video is going to be very special of this course guys, because if you did understand pod lifecycle, then further you will be definitely stuck somewhere and you will be not getting how the pod is working, right? Because deployment set, replica set, all other Kubernetes resources are internally using pod. So that's why guys, before understanding the replica set, first we will understand the Kubernetes pod life cycle. So let's begin today's session. So what is pod? Guys, we already seen what exactly the pod. Pod is smallest unit to deploy applications, right? So to make you understand Kubernetes pod lifecycle, let me write here first Kubernetes architecture, so that you will understand how pod is work internally. So here we have the kubectl. Guys, first we have the kubectl. What we have? kubectl. kubectl क्या होता है? kubectl is a command line interface to interact with the control plane. So here we have in control plane like API server, then we have second component is scheduler, and third component is control manager, third component is etc. So these four components belongs to the control plane guys. So these will be very important in order to understand the Kubernetes life cycle. So first we will understand these, then you will automatically understand how this work, right? So next we have the pod worker node. In the worker node we have four components like pod, and first is the pod and runtime. So container runtime interface. So this is container runtime interface in Kubernetes we have, and also we have kubectl and kube proxy, right? So we already know about the life cycle, so let me just repeat whatever we have learned that in our day 2. Guys, if you haven't watched the day 2, don't worry at all, because we are going to repeat that whatever we have learned in the day 2. So here kubectl is a tool or interface in order to interact with your API server. So it will request to your API server, your request will go from the API server, then your request will goes to your scheduler, then scheduler will schedule and identify the worker node, available nodes, then it will schedule your pod. Then kubectl is an agent, will understand, will read the etcd database and check desired state and current state, then it will pull the image, create the container. So like that how Kubernetes architecture work. So first we need to understand guys, the pod lifecycle. So in the pod lifecycle, right, or pod lifecycle can be divided into phases. So the first phase is guys pod creation phase. What is the first phase? Is pod creation phase. In the pod creation phase, so how and what? So let's see. Whenever you request from this kubelet, let me take one file. So this is the YAML file that we write in our last video. So here you can see we have the YAML file. So we have written this YAML file, and with this we have one board YAML extension. So we have this YAML file, and by using this kubelet we will send this file or request to the API server. So like we have saved this file inside code.yml, then we will write kubectl apply -f and file name. So the moment you fire this command, the request will goes from your terminal to the API server. API server will read the or take the response from the kubelet and store into the etcd. Where it will store? It is going to store inside the etcd. Where? Etcd here. Then it will also it will notify the scheduler, right? It will notify scheduler, right? It will notify scheduler, hey, I have stored the port desired state into the etcd. Now you have to do your work. Now scheduler job is to identify the available nodes and will check the number of ports and how much memory does the port and how much CPU is having there. So based on that, kubelet will create a pod. Kube scheduler will create a pod. Scheduler will create, like pod will like look like this, right? So it will create a pod, then and update the API servers, right? API server is a pull based mechanism, so it continuously watching what happening inside the control plane. So it scheduler will complete his task, then API server will send this request to worker node. So guys, up to here, so this is right when we are in creation phase. This is where our pod state will be pending, right? So this here our pod state will be pending, and when the API server schedule, right? So this is called scheduler state, right? This is called scheduling state, scheduling phase. In the scheduling phase, it will schedule pod, where like from here to here it will schedule this pod as it is, but still your container is not created, so your pod is assigned to the worker node, where in this state, this is called scheduling phase, or the state will be changed to scheduled. Right? So state is got changed. Then here every node is having kubelet, right? We all know about the kubelet. Kubelet is an agent. Agent is having all the information related to the worker node, where inside etcd so kubelet will read the etcd first. It will go to the API server, then it will read etcd, then it will say, right, it will read the configuration or requirement of creating a pod, right? So it will say, okay, I have pod, now I need to put such images. Suppose if we are here in this, we are requesting for nginx image, so it will create one nginx image, right? It will pull the nginx image, and if it will not found the image here, it will get one error, right? If it not get the image, then it will get one error called image pull back of error. So here it will get one image pullback of error. So this is what, if the image, if it find the image, then it will create a container, right? It will create container inside the pod, right? It will create the container inside the pod, right? It will create a container inside the your worker node. This is called container creation phase, guys. This is called container creation phase. Container creation phase. This is called container creation phase. So now your request is came to the scheduling to container creation. Here one condition will be work. If your container is created successfully, then its state will be changed to the running phase. Its state will be changed to the running phase. Right? So this is called running phase, and here status will be run. Here status will be run. Right? So this is status will be run, and here your schedule will be like here to here. So you can see it will look like this, right? So this is called schedule, right? So here let me take this, guys. So it is like a schedule. So status is pending, then it is schedule, then container is creating phase. If it is created, then it will go to the running phase. If it is failed, right? Or let me remove this schedule. After scheduling, here we have if container is crashed. If the container crashed, अगर crashed हो जाता है, then restart state आ जाएगा. Restart. It will restart. So who will be restart the container again and again? Kubernetes will restart container again and again based on the container restart policy. So here container can have application level error or environmental related error. So if the pod running, then it will change to the state in running phase, right? If it's crashed, if it is crashed, then what happened? Restart phase. This is called restart phase. In the restart phase, right? So status will be restart, and in the restart phase, Kubernetes will restart pod and let it shut down, graceful shutdown, right? So first it will give 30 second of segment, right? So here it will give it segment. Let me segterm. It will give the one segterm. So it will give the segterm of 30 second, right? Even after segterm, your container still is running, then it will give segterm kill. In segterm kill, it will forcefully delete your containers, right? So these two attempts also will be happen in the restart phase. So this is also I am putting in the error category. Okay, now so this is running phase, this is restart phase, and finally it have the termination phase. In the termination phase, right? So in the termination, either you can terminate or Kubernetes will terminate. So if you terminate manually, so the request will be crashed and status will be changed to the failure, right? And it will delete your container, it will remove your container from the worker node. So this is called the termination phase. So these are the status of the container. Status of the container, and these are the phases of the container, and this is how, and these are the errors, common errors, right, that we get, and this is how the Kubernetes architecture works. So guys, this is the one of most important video of this course, because in this course you are actually understanding the how the status of the pod work, how the pod phases work, how pod flow in the Kubernetes worker and master node. So hope you guys you are understanding today's video, right? So this is about Kubernetes life cycle. So now next we need to understand the replica set. So this is what our day 7 topic. So let's understand the replica set. So a replica set is what? So replica set is what? Yes, replica set is a Kubernetes resource, right? So why we need this replica set, right? So when we create our pod using the replica set, our Kubernetes, that means we are going to hand over pod lifecycle to the Kubernetes these resources. This time, right, it will ensure zero downtime. It will ensure zero downtime or high availability. High availability, right? It will ensure high availability, and also it will you will be able to you will have zero downtime or self healing. If container might crash or failed, then your Kubernetes replica set will automatically create new pod replacing with them, right? So with the place of that pod, it will create new pod, right? So that's why we are calling replica set is Kubernetes resource, which is automate the pod life cycle, and it will responsible for creating the pod if the pod get crashed, and it will also maintain the minimum pod count. So this is a very important line. It will maintain the minimum pod count. If you give 3, it will maintain always 3 pod. If one pod placed, two pods still are running in your worker node, and it will recreate your destroy or crashed your pod. So this is what the replica set, guys. So now let's create replica set and how we can write its YAML. So for its YAML, I'm creating one file. I'm just creating here a file. So let me call it ReplicaSet YAML, and here we all know. So Kubernetes will start from 3 Let me skip this as of now. So just Kubernetes, when we write the YAML, we have 3 sections mainly. API version will tell which version of the Kubernetes you are going to use for this resource. So it's for API v1 generally we use for this. Then kind, what type of resource you are going to use? We are going to use replica set. Then metadata, basically the metadata about the replica set or information about your replica set. I'm just giving a name is as a replica set. Then we have the spec. What is the spec? Spec contain the actual requirement of your Kubernetes replica set in pods. So here we are going to define. So it will if this spec is having number of containers. Spec is having containers, but when we create the replicas, here you will have the number of replicas. Number of replicas. This is main replicas. So this is very important part of this. So here we are giving we are telling this Kubernetes, hey Kubernetes, I want to running minimum 3 pods every time. So this, because of this feature, we are getting the high availability, right? Then we need to give the selector. Right? So selector is having match label. So this match label like having the name, like I'm giving the app and ng app. Simple, we are going to deploy the ng, that's why I'm giving. Thereafter we have the template. In the template we have the metadata and metadata is having labels like what level we have given here, that same level we need to give, because the selector is used to identify your code. Then metadata, after the metadata we have the spec. So here metadata, then metadata hai, then we have the spec. Spec contain your container information, containers. So we have the containers, like let me give one container name is ng app pod, right? So this is pod. So container we are giving one name, and we need to give the image. So here I'm giving the image. What is the image? Nginx. This is my Nginx image. Then I want to give the pods. So pods, it's array. So I'm giving the container pod. So container pod is for Nginx is 80 is default. So this is how we can write YAML for our replica set. So let's try it into our editor or our cluster. Here our cluster is ready, guys. So let me check. We have one folders. Let me go Kubernetes. Here let me check files. So here we have the ReplicaSet YAML. So let me remove this file and rm -f replica. So I have removed this file, and I want to create new file, nano and replicaset.yml. So you can give either YAML and YML, both will be valid. And here whatever YAML we have written for this, just let me copy this, and I'm just copying as it is, and let me fix the issue if there is any issue. So the version apps replica set metadata spec replicas app nginx. So okay, let me save and exit, control O and control X, and here we need to kubectl apply -f replica set. Let me check it will create or not. So okay, our file is having some issue. What issue? So unknown field spec metadata. Okay, indentation issue we are getting. So let me fix the indentation issue, so that metadata then spec replica basically inside 1 2 3. Okay, this is okay. And 1 2. Okay, so 1 2 3. Okay, this is okay. Then template. So this is the template. Okay, exactly replica set template metadata, inside metadata then we have label, and this label also is one indentation only. Okay, so it is like an object, so labels. Okay, then we have the spec. We have the spec inside the metadata. We have the spec container. Okay, oh yeah. So hope this will work. Let me fire this again. So the error converting YAML to JSON, line number 13 did not find the expected key. Line number 13 is having still issue. Okay, let me save this and exit. Something went wrong. I think we need to check it, guys. So let me exit first. I will want to save first. Let me check what is the issue. Here we have the indentation issue. So replica selector, then we have the template, inside template metadata labels. Okay, so spec is wrong. Okay, spec is wrong. Spec is also inside this. So here spec, then we have one space to the container, then one space to this, one space, and one space. Let me see. Please save this and fix. Then let me run. What happened this time? Let me kubectl apply hyphen f replica set. Yeah, so indentation issue was there, so yeah, it got created. So whatever YAML that we have written here, let me fix that as well. Here we have the match label, and inside match label metadata we have the labels, templates. Okay, this is one issue, we need to go one step away, right? So now yeah, this is okay, and here is also labels. Okay, so yeah, this is working. Now this will work. So this is how you can write your YAML. So let me check the behavior of this. So kubectl get port. So we have 3 ports are running. How many ports are running? So we need to check if we delete the port, is replica set really will recreate this? If it is so, that means our replica set is having self-healing auto recreating ability. So let me delete one port. kubectl delete, and I want to delete port, so I want to delete this port. Let me check the behavior of this. So we are going to delete one port, and we'll see is Kubernetes replica set is going to create this port again or not. So this is what we need to understand. Something, yeah, it's get deleted. Let me check this time. Get ports. So yeah, port is in terminating state, right? So Kubernetes is going to gracefully deleting and destroy the container, and sometime later it will recreate container. It will read. So as of now, you can see having 2 containers, 2 ports are running. Container here it will check. It will check here. Replica set will check desired state and current state. So desired state and current state. Desired state will 3. So it will check desired state and current state. Which is state? Current. So if current state doesn't match to the desired state, right? So that means it will create one port. It will create one more port. So here already 2 ports are running, right? 2 ports, one port in one worker node, another port or second port is running in another worker node, and third port it going to create inside the first worker node. So this is how the Kubernetes work and replica set work, my dear friends. So if you like today's video, please like this video and subscribe to our channel, so that whenever I upload new video you will get notification. Thank you for watching. Let me something. So pending, studies in pending.